Welcome back to the course on architectural design of ICs. So, in the last class we have seen the that means architectural design of GCD, okay. And then again today we will see another function which I want to implement, that is, and then again we have seen the architecture of how we can, that means, implement x into 2 to the power of n. So, today again we will see another function if I want to implement, that is y equals to 2 to the power of x. How can I design that? Okay. So, whenever we will just start with this, what function I want to implement, that is y equals to 2 to the power of x. So, these are why I need to learn this basic, that means what is the architecture of this kind of functions, because these are the basic function which is very much required whenever you are building your final circuit. That means suppose you are building one F50 operation or one DCT operation function or one this DST function. So, at that time these are the basic operators which you require to implement the final expression or final function to be implemented. Okay. So, that is why the optimization, it is something like this. What happened, that means it is something like this. What, suppose you are building a home, okay, and home is basically built by brick, right. So, if you can reduce the cost of each of the brick whenever you are building the home, obviously you will save more amount of money. So, here also we are trying to do that thing, that means if this building blocks or this operator level optimization, if we do whenever we implement the final function which can use 1000 times of this particular operators in the for final implementation of those functions. So, at that time I can get more on of the benefit in terms of whether that is in terms of power or in terms of area. So, that means that is why we are targeting to the operator level optimization, and obviously there are algorithmic optimization and in the higher levels of abstraction if you just follow. So, at that time each of the levels has been its optimization technique, but here architectural optimization we are trying to find out at the basic operators level. Obviously, we will see some of the, that means functional level or optimization, how we can do design or what is the architectural changes we do to get the optimized circuit or efficient circuit for those functions to be implemented, that we will see in the later of this course. But here at this particular point we are being started with this operator level optimization. So, here another example, that means function which I want to implement, that is y equals to 2 to the power of x. Okay. So, how to find out this, that means what will be the circuit for this y equals to 2 to the power x. So, if I just draw the, that means circuit of, that means the truth table of this. So, at that time if I consider 4 bit of x, that means x is of that means 4 bit. So, that means now x3, x2, x1 and x0. Okay. So, for this 4, y will be of what? That means it will be of 16 bit. For considering this, it will be of 16 bit. Okay. So, let us consider P15, P14, P13, P12, sorry, P11, P10, P9, P8, P7 up to P1 and P0. Okay. So, if I just draw it something like this. So, at that time what will happen, for all zeros of x. So, this means what? 2 to the power 0, that is equals to 1. So, that means at that time only this P0 will be 1 and rest of the all bits will be 0. Okay. For x equals to 1, for x equals to 1, y equals to what? 2 to the power 1 means 2. That means only this P1 position is 1 and rest of the positions are all zeros. Then again if I just come to 0 0 1 0, so that means here for x equals to 2, so this is 4. So, that means only P3 position will be 1 and all other positions will be filled with zeros only. So, the same thing if I consider that x value is as, that means 0 1 1 for 7. Okay. So, 7 means 2 to the power 7, that is equals to 128. So, 128 means this P7 will be 1 and rest all are will be 0. So, that means if I just draw a connection from this, if you just see at this particular position changes of x, this only, that means changes. So, if you just make a connection with the corresponding digital circuit, if you see that this is nothing but a decoder circuit. Okay. So, in decoder circuit what happens? So, whenever, that means for this particular bit position we basically decode and that gives me the corresponding 1 value, right. So, if I just, that means from this particular decoder circuit means what? So, I am having this 4 input and I will have the corresponding 16 output over here. The same circuit I am getting for y equals to, that is nothing but the function of y equals to 2 to the power x. From truth table we can conclude that particular thing. Now, what will be the, that means circuit for this? If I want to draw the corresponding decoder circuit from this particular truth table, how it will look like? For that reason, what I have to do? I need the AND gate, so here also the same thing at this particular position. Okay. So, this is x3, x2, this is bar, this is bar, this is x1 and x0 bar. So, then this is x3 bar, x2, this is x3, x2 bar and this is x3, x2. Okay. So, that means this is for 0 0, this is for 0 1, this is for 1 0, this is for 1 1 and this is x1 bar, x0 and then x1, x0 bar and this is x1, x0. Okay. So, now if you just make the lines, draw the lines from this particular point, so if I am having one AND gate over here which is connected with this, so what is the values of this? Here what is, that means this and this, if it is ANDed, and then again these two particular results, if this is P3, this is P2, this is P1, this is P0, sorry not P again, this is, if this is Q, if I consider this as Q, this is let us consider Q3 dashed, Q2 dashed, Q1 dashed and Q0 dashed. So, here what I will get? I will get this is as P0. So, why P0? P0 is what? Nothing but x3 bar, x2 bar, x1 bar and x0 bar. Okay. So, if you just go back to that. So, for P0 whenever all are 0, so at that time P0 is 1 and rest are 0. Okay. So, here for this only this is P0. Okay. For this, if I just connect to this, so then this is P1. Okay. Then again if I just, this is P2. This is P3. So, you see here this is for 0 0 and this is for 1 1. So, this is the case of P3. Okay. So, actually that means for each of the case now you can find out using the same thing. So, this is for P4, this is P5, this is P6, this is P7 and this is for the other case, this is for P8, P9, P10, P11, then this is for P12, this is for P13, this is for P14 and this is for P15. That means, now if I just draw this particular, that means if implement this particular function, I can get y the function implementation of y equals to 2 to the power of x. Okay. So, this is the circuit for implementing 2 to the power x. Now, next if I want a that means function which is 4 to the power x or 2 of 2 to the power x. So, at that time how can I do that? So, that means 4 to the power x means at that time what will be the output size of 4 bit, the size will be of 32. So, that means where will be the, whenever I will do that means this. So, 4 to the power x means it will changes from, that means how it will change, whenever this is 0 that means this is 1, then 4, then what, then 16, then for 3, 4 into 4 60, 64, something like this, this will change. So, if you just see that means for 0 0 1, for 4 what is that, for 16, for 64, something like this it is changing, all other bit positions are 0. Okay. So, again that means from the 2 to the power x function, 2 to the power x function we have derived. So, what was the logic there? It is changing 1, then 1, then 1, then 1, something like this. But here if you see that these positions is 0, this positions is 0, this positions is 0. That means the alternate positions are filled with all zeros for 4 to the power x. So, that means now from the 2 to the power x circuit, I can easily implement 4 to the power x function by putting something like this. Suppose this is the 2 to the power x function which I have already implemented earlier. So, here what I need is so that means initially it was P0, now this will become P2, this P3, this is P4, this is P5, this is P6, something like this. That means all the even position that are filled with zeros of the 2 to the power x function. Okay. And this will give me the whole of this circuit is nothing but the 4 to the power x. Okay. So, this is the that means circuit which I can implement using this, that means using 4 to the power, that means 2 to the power x, I can implement 4 to the power x 2. The same thing if I want to implement 8 to the power x, at that time how can I design? That means at that time 8 to the power x means 2 corresponding bit position will be filled with zeros, that means alternate 2 bit 2 to the power x function. So, at that time what will happen? 4 to the power x from this particular circuit, how can I implement? So, 2 to the power x. So, then P0 is P0, then 2 bit positions are filled with 0, then this will be this its P2 will be connected to this here P1, sorry, this is if this is P0, this is P1, this is P2, this will be P3 here, and its P1 will be its P3. Okay. So, that means any value of 8x or 16x or any values can be implemented using this 2 to the power x, but hardware wise there is no changes. Once you just this using this gate level you have implemented the 2 to the power x, then you can easily implement the other function of this. Okay. So, this is for like the implementation technique for 2 to the power x, then 4 to the power x, then any of this. Okay. Then using this 2 to the power x as the base function, what are the other function we can implement, that we will see in the next, that means in the next. So, now next you consider y equals to 2 to the power x plus 1. Suppose this function I want to implement. So, at that time what will be the changes? Okay. So, that means at that time if I just want to add y equals to 2 to the power x plus 1. So, at that time means what? For 2 to the power x, for this, for 0 0 0 0 it was all 1. Okay. This is 2 to the power x. Then I want to add it plus 1. Okay. So, that means this will now this modified will become, and rest of all bit will be 0. Then for 0 0 0 1, this is 0 and 1, and what it will be? It will be this. Okay. Then for 4 it is for 2, this is 4. So, now it will be 5. Okay. Then again for 3 it is 8, but here it will be 9. Okay. So, you just see that for adding at the, that means adding of 1 to 2 to the power x, how it is basically affecting? It is affecting this last 2 bit position only. This rest of the bit positions are basically remain same. It only affects the last 2 bit position. So, here what happened? It becomes just inversion of the P0. That means, if you consider in the earlier case it was 1 and rest of the bit was 0 for this, but here what happened? This has become 1, but rest of the all cases became 0. That means, from this particular logic, if I just then this P0 modified or P0 of this particular circuit, that will be what? If this is the P0 from 2 to the power x, and whereas the changes other, that means here initially this was 1, 0, this was 1, but here now it becomes 1, because of what? Here for 1 plus 1 that carry has been generated and that has forwarded to this particular bit position. Okay. So, that means now to do that, what will be the P1 bar? What will be the P1 bar now? Okay. So, that means now P1 bar is basically dependent on this corresponding P1 and P0 value. So, P1 and P0 value, that means initially this position was 1, right, and in the modified, because of this that means addition of 1, now it becomes 1. Initially for 2 to the power x this was 0 and this was 1, but here it is, as this is 1, so it is 1 only. Only for this particular bit position I need to change. That means, for this P0, and this will be changed. So, how this will be changed? If I just do it, that P0 plus P1, that is equals to modified of P1, then that will be the case for this. How? For this, if this was 0 plus 1. So, in the modified case P1 will be 1. For this, what was the value? 0 and 1. In this case, this is 1, this is 1. In the other case, what it is? It was 0 plus 0. So, that means, in all other cases it will be 0. And for rest of the case, as this carry is not affected on the third bit, so that means it will remain same. Only in the last 2 bit position this 1 will affect, and that will be the change which I need. So, then what will be the, that means corresponding architecture for this? So, if you just draw the architecture of this, then this and you require one, this is the P0 modified, this is P1, then rest are just same as this is the 2 to the power x function, this is x. So, this circuit is basically nothing but your 2 to the power x plus 1. So, that means only in these 2 particular bit position I am having the change to make it 2 to the power x plus 1. So, now if I just want to add this 2 to the power x plus 2, then what will happen? 2 to the power x plus 4, then what will happen? If I just want to add any values with 2 to the power x, so at that time how it will affect and what will be the change, or how easily or how efficiently we can implement that circuit, we will see along with many other new circuit. Using this 2 to the power x as the base function, how we can implement that we will see in the next few classes. So, thank you for today.